All right, so we're going to do something a little bit different here. Rather than a scripted video, I'm just going to talk about a couple of subjects, a couple of science-denying, globe-denying subjects. We're going to talk about rockets and relative density. We're going to apply a little logic and critical thinking. Yeah, I know a bunch of you science deniers, globe deniers out there are thinking, what's he talking about? Because unless you're a science denier and globe denier, you don't even know what critical thinking is, let alone how to apply it. Well, I'm going to show you that the rest of the world can. The 99.99% of us who aren't science and globe deniers can actually do critical thinking. And then what we're going to do is we're going to show that why those two subjects, rocketry, working in a vacuum, and relative density, don't make any sense. So, I'm Mike the engineer. Let's cue the intro. Thank you, Riders of Dinosaurs. So, as a representative of the typical explanation of relative density as the force that makes things fall, I'll use this quote from Matthias the Walking Witness. I'll read it to you. Relative density. Objects will either sink, float, or rise in a medium therein, depending upon the density of the object relative to the medium, i.e., number 1, a helium balloon. A helium balloon rises through the medium of air, cause helium is less dense, rises than the medium of the air surrounding the helium balloon, i.e. 2. It probably should be EG, but an apple. An apple sinks through the medium of air because the apple is more dense, sinks, than the medium of the air surrounding the apple, i.e. 3, equilibrium. A rock sits on the ground in the state of equilibrium. You decide to pick up the rock, however, by doing so, you're taking the rock out of its natural state of equilibrium. You then decide to drop the rock, causing the rock to sink through the medium of air to sink to its natural state of equilibrium, i.e. 3.1. So the apple sunk through the medium of the air, but this time it lands in a pool of water. The apple sinks through the thick density of the water to find out that it went too deep, and decides to rise due to the apple being less dense than the medium of water to the top of the water to seek its equilibrium state. The apple decides to rise. Made a conscious decision somehow. So, Matthias tells us that apples fall off the tree to the ground, or if they fall into a pool of water, they float. He also tells us that if we let go of a helium balloon, it'll float up towards the sky. That if we pick up a rock and let it go, that it will fall back down to the ground. Well, thank you, Dr. Obvious, the world's foremost authority on the incredibly apparent. These are nothing but claims. Well, actually, those are descriptions of what physically happens. But then he claims that all of that happens due to relative density. That's just a claim. There's no evidence there. The density between the apple and the atmosphere is different. But where in all of that hand waving that you've got there do you tell us that the relative density applies a force and that the most likely cause for things to fall or float is relative density to the exclusion of any other probabilities, including gravity, by the way. Provide no calculations, no observations, no measurements for any of that. And yet, claim it is what it is. Then you post a meme. You posted a meme saying that globers make claims but don't provide evidence, and that a claim is not evidence of itself. Hypocrite much? Because it's exactly what you just did. And you post that same thing over and over. You cut and paste that relative density thing constantly. So what? Let's look at the claim that relative density is a force, and that is the reason why things fall. Let's look at what that means. Let's say I've got a lawn dart. You guys can look up lawn darts. They were a game in the 70s, 60s and 70s for backyard, kind of like horseshoes. You had a ring, you had a dart about 1.5 feet long, and that dart you would throw up in the air and try to land it in the circle. So 1.5 feet long steel-tipped darts, giving that to kids, in particular adolescent boys, what could possibly go wrong? Yeah, after thousands of injuries and 4 deaths, they were banned in the United States. But let's say I've got a lawn dart that's made out of tungsten, pretty heavy, and that gives us a large relative density. The magnitude of the difference, capital delta, is usually the symbol used for difference, and rho is the density. So the magnitude of the difference between the atmosphere and the object, the lawn dart, the delta rho, if we're to believe the science denier, globe denier claim that relative density is a force, well, that delta rho is what provides that force. So what do we know? Now I take that lawn dart up to a 4,000-foot cliff, I drop it off, what happens? It falls. It falls at a constant acceleration of about 9.8-ish meters per second squared. This is something that's not disputed by anybody. It pretty much is what it is. There's nothing to show that that acceleration changes while things fall. As a matter of fact, we can easily demonstrate through just dropping stuff that constant acceleration remains constant. But here's the problem with that. As the object falls the 4,000 feet, the delta rho up here is a bigger value because the density of the atmosphere is smaller. The delta rho at sea level, 4,000 feet down, is a smaller value because the density of the atmosphere is larger. But yet that acceleration remains constant. So even though the magnitude of delta rho changes from top to bottom, the acceleration remains constant. Now, we could argue that we could also, the force that is applied is weight. It's easy to argue that. Okay, so the delta rho provides a force that we can measure. It's weight of the object. So now I take 2 objects up there. I have 2 lawn darts. One's the tungsten lawn dart. The other one's made of magnesium. Much, much less dense material than tungsten. So delta rho is larger between it and the atmosphere. Yet, if I drop them both at the same time, they both fall with the same acceleration and they land at the bottom of the cliff at the same time. So, it seems that the magnitude of that delta rho, that relative density between the medium and the object, is irrelevant when it comes to the acceleration on that object. That somehow there is some other consideration here. There's something else going on. What's the difference between those 2 objects? Well, obviously their weights. Their masses are different. So somehow, not only does relative density provide that force to make things fall, but it also has to have some component related to mass. Otherwise, how would there be different forces applied? Now, you could go back to argue that the difference of forces applied is because they have different relative densities. The magnitude of delta rho is different for the tungsten long dart than it is for the magnesium long dart. But the problem with that is we know that acceleration and the force, the weight measured of those two long darts, remains constant from the 4,000 foot height to sea level. So that relative density isn't proportional to the force applied. In other words, if relative density changed, then that force should change, and it doesn't. So there's something else going on there that relative density itself, all by itself, isn't accounting for. Now, we know that if we take the force applied, the weight of the object in newtons, multiply it by the mass in kilograms, actually divide by the mass in kilograms. So we take the force divided by mass, we get an acceleration. And the proportionality will work out. We take the force applied, the weight of the long dart, divided by the mass of the long dart, and it should get you about 9.8 meters per second squared. So why isn't that acceleration proportional to the difference in density? Why changing that difference in density, that delta rho value, doesn't have an effect on that acceleration? Why is that, if relative density is a force? So it must not rely at all on the magnitude of that delta rho. Well, let's look at it from the other perspective now. Let's look at Anthony Riley's neutrally buoyant egg demonstration. One of my favorite demonstrations of all time, because it's so cool to change the height of the egg and not make it float on the bottom, on the top, not sit on the bottom, and actually just make it neutrally buoyant in the middle of the water column. And Anthony even went so far as to say, yeah, it's been sitting all night, so the density isn't even through the glass. And he stirs the glass and says, watch, the egg will rise. And it does. It actually rises in the water column because now the density of the water is even throughout. He stirred it up. That's a very cool demonstration. And he even added more salt, and sure enough, the egg rose. So there's a problem with that. Minute changes in relative density between the medium and the object causes the object to move from the higher density medium at depth to some lower density medium higher up in the water column. Eventually, if you add enough salt, the egg will be floating on the surface. And that's inconsistent with what happens for things we drop through the atmosphere. Drop through the atmosphere, the acceleration on the object we're dropping is unaffected by the magnitude of the differential density, the delta rho value between the medium, the atmosphere, and the object are long darts. Why then would a minute change in that relative density in the water column cause such a big effect on the egg? And not only that, in the water column, the egg moves from a higher density medium to a lower, which is kind of what you would expect, because if you would expect that if relative density did something, it would cause it to move in one direction. Except that in the atmosphere, it goes from a lower density medium to a higher density medium, which is what you would expect. It would go from one relative density to another. But why doesn't it do the same thing in both directions? Why is it different in a water column than it is in air? And how come we cannot create a proportionality between the force applied and the density of the atmosphere on our object? Let's talk about a scale. Kind of like the scale that, like the Lady Justice holds. She's blind, she's weighing the scales of justice. Only instead of having two plates, it's got two cylindrical cups. One cup I put 2 liters of water.
The other cup I put 1 liter of water. Well, obviously we know that the one with the 2 liters of water is heavier, so the balance will shift to the heavier side. Yet the relative density between the atmosphere and the water is the same for both. So why is the force different? Why is the weight different? Well, it shouldn't be different, should it? It should be proportional, and it isn't. So there's another component that's missing here. There's something else acting that's not being taken into account. So here's the summary of all of this relative density stuff. Either you can explain how in an atmosphere the relative density and the force applied to the object is not proportional to that delta rho value, to whatever it happens to be. Why doesn't it change as the relative density between the atmosphere and the object change? And yet, that neutrally buoyant egg in the water moves under minute changes in relative density between the water and the egg. Why is that? So if you're going to make the claim that relative density is a force and the reason why things fall, Matthias the walking witness, are you listening? You've got to provide some evidence that shows, 1, the relative density is a force. 2, how it works, how it's applied. And 3, some calculation, measurement, observation that shows relative density is the most likely reason for things to fall, to the exclusion of all other probabilities. And by that I don't mean, well, the apple's more dense than the atmosphere and it falls, so that must be the reason. No, that's not evidence of anything. That's a claim. It's not evidence of itself. So, unless you globe deniers can explain those things, then relative density is nothing but a claim that is not worth talking about beyond this. This will be the last time I talk about relative density, and it should be the last time anybody talks about it, unless you guys want to start providing some evidence. Let's move on to rockets.
So a while back, in a video done by Wolfie6020, and there'll be a link to that video in the description, because it's very good. And if you're not subscribed to Wolfie, you should, because the man's awesome. He's very, very sharp, and there's a lot of really good information and data. You can learn a lot from him. I have. So he started, this guy, New Perspective, started a comment thread under his video. Now, I've taken to copying these comment threads that I reply to, because especially in situations where I've commented on people's videos and in their threads, that they hide my stuff. And sometimes my comments have even been deleted. So I've taken to, not only taken screenshots, but I just copy the whole thing and dump it into Word. So little Mr. New Perspective here, we started out a thread saying, anyone here with a degree in physics? Well, you know that's a leading question here. He's looking to start a discussion about something in particular. And he goes on to say something in particular about simulate thinning, thrust. He talks about rockets. And basically he says that rockets can't work in a vacuum. Says Newton's third law does not work in a vacuum, which is kind of interesting to say, because it's either a scientific law that works or it doesn't work. It doesn't have conditions as to when it can work. But that's neither here nor there. So I come back to him, and my first comment was, interesting that in this subject keeps coming up in videos completely unrelated to rockets, because I've seen quite a few science deniers bring this up in videos that have absolutely nothing to do with rockets whatsoever, like Wolfie's. So I asked him to give me a equation for the rocket thrust in how it works in the atmosphere, how it includes atmosphere as part of its way to work, because he says it doesn't work, it needs atmosphere to work, and a free body diagram, which he doesn't do. He links me to this video here, which I will link to in the comments section so you guys can see it. He, I guess, thinks that this is his version of a free body diagram, which it is not. It's total crap. So, it goes on a little bit, and he has a whole lot to say about free-falling bodies and Newton's third law, and I come back with this comment. So nowhere in any of your comments do you provide the equation I asked for, because he like slams me, tries to slam me up further up. Nor does any of your comments contain an explanation of how forces are transferred from the atmosphere to the rocket. And in that video, he provides this, which is basically the area is the true area of mass-on-mass reaction, and due to the atmosphere, there's no internal recoiling upstream from the choked nozzle flow. He's obviously talking about the rocket nozzle. So he's saying that there's no way to get force from the exhaust gases up to the rocket body itself. And that this is the real reason your rockets can't function in space. I said, this is nothing but a claim and completely contradicts the current model, and you provide absolutely no evidence to support the above claim. Where in any of your comments do you show that atmosphere can supply a reaction force to approximately 10 million pounds of thrust without moving out of the way? I was talking about a Saturn V rocket. The interesting part is he doesn't answer this. So in the pinned thread under Wolfie, I asked him, so are you going to answer my question? And his reply to me was, sigh, what question? Literally, that's what he said. So in Wolfie's pinned thread, I asked him to answer my question. Are you going to answer my question? Because he's just abandoned the other thread completely. And this was his reply, Mike Bertelson, sigh, what was the question? As if, I'm just somehow annoying him. So I posted a link to his to my comment under his thread, and then he completely ignores me, and I ask him, so are you going to answer my question? And he asks, what was the question? And I link to that thread again, and lo and behold, this thread, this whole thing, he deletes. He obviously deletes his first comment in the thread because the whole thing went away. Lucky for me, I copied the whole thread before he deleted it, so I still had my thing. So I went and posted it under Wolfie's pinned thread and said, okay, well, if you deleted the other thread, because why? Are you afraid to answer my question or what? So I said to him, well, here's the question, and I just copied and pasted this into there. Turns out now that the half a dozen or so comment threads that he started and all of his individual comments in other threads are now gone from Wolfie's video, his comments under that video. It's interesting, too, because there's a lot of people that, at New Perspective, and in no way does that make any sense, because he doesn't exist anywhere in the threads. It's kind of interesting. It's either that or he's got me blocked somehow. All right. So what we're going to do is we're going to take this claim that rockets can't work in space and that they must need an atmosphere to push off of. And we're going to look at it with a critical eye and see how this goes.
You can see, New Perspective just flat out ran away. He didn't answer the question, deleted all his posts so he didn't have to answer the question. I think I've got him now. I went and replied to him directly on his own channel, on his own videos. See how long it is before he blocks me. He's probably already got me hidden though. When I was in the Navy, I was stationed in Orlando at the Navy base. I went to Nuke Power School down there. I got lucky enough to go see a shuttle launch. We drove over to the Cape and watched one of the shuttles. This was late 81, early 82, sometime in that time frame. So I could probably look it up, but it was definitely one of the most impressive things I'd ever seen. It makes me wonder what it must have been like to see a Saturn V rocket launch. That would have been phenomenal. Here's a rocket that has 10.5 million pounds force of thrust. So, are we going to say that the atmosphere can resist that without moving out of the way? I wonder how that is. Let's talk about a glass of water sitting on a table. You put that glass down on the table, what do you notice about it? Well, other than obviously the glass sitting on the table, you know it's motionless. And what does that mean? That means that the net sum of the forces on that glass are zero. An object at rest stays at rest, right? Well, we do know that the glass has weight, right? The glass and its contents exert a weight on the table. So there is a force there. Well, it turns out that as long as the table is sufficiently strong, it provides a reaction force, a normal force to the weight. So you have the weight of the cup and its contents and the reaction force of the table in the opposite direction, opposite signs. They sum to zero. It's motionless. In most sciences, it's called a normal force. In engineering, we call that a reaction force. So is that what's happening here with a rocket and in its atmosphere? The atmosphere provides that reaction force for the rocket to push off of. Well, how does it do that? How does it do that without being pushed out of the way? It would need something to push off of, so maybe the atmosphere is reacting like a non-Newtonian fluid. I'll link a video in the description about non-Newtonian fluids. But basically, you can make it out of just cornstarch and water. And you put your hand on the surface of the non-Newtonian fluid and you can just push in and it goes right in. Now, if I were to slap my hand down, the viscosity goes way up and it stops. My hand can't go past the surface of the fluid. I can hit it with a 3-pound sledgehammer and it will not go in. It'll just bounce right off. So is that what's happening with a rocket? Does it somehow cause the atmosphere to act like a non-Newtonian fluid so it has something to push off of? A Saturn V rocket puts out about 10.5 million pounds of thrust, but it also weighs about 6-point-something million pounds. So all told, 16 million pounds of thrust and rocket weight. Are we trying to say that even if it is a non-Newtonian fluid, that the atmosphere can resist that much force to provide the necessary reaction force for the rocket to lift off? The exhaust gases coming out of the rocket impact the atmosphere. Well, I just realized something. Well, you know what? We'll get back to that in a minute. So the exhaust gases impact the atmosphere. The atmosphere, being a non-Newtonian fluid, resists it, and it pushes off of it. Except we don't see the atmosphere do that. I can walk through it. I don't have a force in front of me that's equal and opposite to the force I'm pushing on the atmosphere with. My car, driving down the road, same thing. I don't get an equal opposite force to my car pushing on the atmosphere. Maybe it has something to do with the rocket having so much thrust. There is so much force applied to the atmosphere that it reacts like a non-Newtonian fluid. Well, that doesn't work either, because I can go down to the hobby shop and buy a model rocket that literally puts out ounce-pounds of force. And yet they fly. Ballistics, the bullet coming out of a gun. Very high velocity. Relative to your car, very high velocity. Yet that bullet doesn't have an equal and opposite force of the atmosphere reacting against that bullet go flying through the atmosphere. The round out of a 16-inch gun on an Iowa-class battleship. That's fine too. That's able to fly. How are all these things able to do what they do if the atmosphere is going to react in such a way that it provides an equal and opposite force to whatever is impacting it, whatever's pushing it against it? But now back to the thing that I just thought of a couple of minutes ago. If the exhaust gas is on a rocket, it can either do one of two things. It can impart a force on the rocket body and the rocket will fly, or it can't, in which case it won't move the rocket on its own, which is the science-denying claim. In a vacuum with nothing to push against, the exhaust gases won't move the rocket. So one of two things is true. Either the exhaust gases can move it or they can't move it. Either way, whatever it does, it can do in both a vacuum and in the atmosphere. If those exhaust gases can't impart a force on the rocket itself to move the rocket in a vacuum, then it certainly can't do it in an atmosphere either. The exhaust gases come out, they impact the atmosphere. How does that reaction force then get back up to the rocket? How does that work? All without the atmosphere being pushed out of the way. Now, if the exhaust gases can impart a force on the rocket, well, then it can do it in a vacuum too. So all you science deniers out there who want to make the claim that a rocket won't work in a vacuum, you should realize that as we've just discussed, it is a self-debunking claim. So unless you can show how the exhaust gases can push on the rocket after hitting the atmosphere, but it can't push on the rocket at all anywhere else, how does the force of those exhaust gases get back to the rocket? Can you explain that? I bet you can't. Bet nobody can. I can't wait to see how these work out. Well, I'm Mike the engineer, and I think we're done looking at stuff with a critical eye.